So, Maria, are you ready?
I'm ready.
Awesome. Okay, so I'm happy to welcome all of you to the OTF Connect session, Nurturing Quality Thinking in Mathematics in Junior Intermediate. And I'm going to let Maria introduce herself. It's really great to see people from all over Ontario participating in these OTF Connect sessions. And I'm going to now hand it over to Maria. So thank you very much for joining us.
Thank you so much, Molly, and welcome to everyone. I really appreciate you taking time, obviously from your very busy schedules, and being together tonight. My name is Maria Van Belise, and I am an educator here in Ontario. I've been teaching for over 16 years. But over the last 4 years, I've been working with the Critical Thinking Consortium. I had started working with a consortium in terms of incorporating some of their ideas into my classroom early on in my teaching, and found that it has made such a difference. And so I'm excited to continue to develop those ideas and share those ideas with teachers as we're all committed to really nurturing thinking in our students and helping them to see themselves as great problem solvers and world shapers. So I'm really excited to be here. I did want to ask how many of you have done a session with me before in mathematics. If you could just use the tool that Molly mentioned, the yes-no tool, that would be great. Okay, so I'm not sure if I'm reading that correctly. It looks like it's either 41 or 4 who have done one before. Molly, are you able to see that? It's 4. Okay.
Yeah, I think it's 5 now. For some reason,
okay.
it does look like 51.
Yeah, I know. I was like, I didn't think there were that many as I was scrolling down.
Yeah.
So for those of you who have been in a session before, definitely I'm going to be revisiting some of the core concepts of the framework, but I will be sure to differentiate when we hit those parts and give you, just another prompt as well to consider as we go over some of that really core terrain of critical thinking. So I did want to let people know about contact information up front. Some people do like to tweet during sessions, so I wanted to give you my Twitter handle and just give that information up front. And also, if you at any point want to ask me questions, I'm always really happy to hear from you. And teachers sometimes will troubleshoot together on a particular lesson idea, and I'm happy to hear from you. So please be sure to take down that information if you'd like to be in touch. And of course, the TC2 website, which I know Molly will be posting after the session when you'll get the link and all of the supporting resources. So I have a question here, and you'll notice that the criteria is missing because I wanted to give you some choice. I wanted to give you a choice of 3 criteria. To think about what is one of the most either important things you already do to nurture quality thinking in mathematics, what's one of the most impactful things you already do, or what is one of the most exciting things you already do to nurture quality thinking in mathematics. And if so, again, it's either important, impactful, or exciting. And if you want to take a moment and use the text tool or either in the chat box, it's up to you, whatever you're comfortable with. And take a moment, because what I love about these sessions is we get to actually connect with teachers across the province and hear about the amazing things that everyone is doing in their classrooms already. Number talks are amazing, open-ended questions. Which one doesn't belong? Open tasks, real-life investigations, Fosno strings, open-ended questions, appreciate ways of knowing and communicating, embrace and acknowledge different ways of finding an answer, Absolutely. Using visualization, exemplar student voice, math congress and gallery walks. Encourage risk-taking. Problem of the week from Waterloo University. That's really excellent. All of these are just excellent things. And again, I always get so excited to work with the amazing teachers in Ontario. Okay, well, thank you for sharing that. And if there's more, please feel free to add them. So we can see that, you know, you're already incorporating some really powerful and exciting instructional strategies. What I want to focus on tonight, I want us to really spend the time thinking about the thinking, the conceptual thinking, the critical thinking, the quality thinking that we are really trying to nurture in our students. Oh, and Maria mentioned new tools, would you rather, estimation 180, notice wonder, numberless word problems, trying to up the conversations about math and reasoning. Excellent. So John Van de Waal, who I think, you know, when we were in, you know, our pre-service programs, you know, this is the core mathematics textbook, was written by John Van de Waal. And he says pretty explicitly that no matter how patiently and clearly we explain, we cannot think or learn for our students. And I think that sometimes in mathematics in particular, we struggle with how much we really explain to our students and try to tell them whether the answer is right or wrong, and inadvertently put ourselves in the position of being the learning umpire over the learning coach. And Van de Waal really reminds us that we have to ensure that we're setting up tasks and creating a classroom climate and culture where it's the students who are doing the thinking. At the Critical Thinking Consortium, we've developed a taxonomy of engagement. And I think it's really helpful when we think about intellectual engagement. The studies, the Canadian Education Association did a study in 2009, What Did You Learn in School Today? And they interviewed about close to 70,000 students across Canada. And it was quite interesting that they found that students, the social engagement with school was very high, the institutional engagement was high, and that students felt that there was you know, value in going to school. They could see it, you know, they could appreciate that. But their level of intellectual engagement started very high, you know, in the primary grades, and consistently declined until secondary school, where it was quite low. So what's happening so that our students are becoming less intellectually engaged? And where are we targeting our tasks? And if we are really looking to challenge our students and transform them in terms of their cognitive and intellectual growth, then we need to ensure that the tasks we're setting up are inviting the kind of critical, collaborative, creative, and conceptual thinking that is needed to provide that kind of intellectual engagement. And that's what the focus of tonight is to really look at how do we bump up the thinking in our mathematics classroom. Again, from this study, I just wanted to point this out. I think it would be interesting to a lot of teachers. What we noticed from their research in 2009 is that when students do not have a high level of skill and are not being challenged, then they're feeling quite apathetic about education and school. When they have a high degree of skill and aren't being challenged, they're likely to see little relevance or will be quite bored. When students do not have a high level of skill, you know, that some of the, we're going to call these the intellectual tools, and I'll talk about those. Students are then quite anxious and apprehensive about learning when they're being challenged, but they don't feel they have the tools to engage in the challenge. And the sweet spot that we're all really trying to get at in our classrooms is to scaffold and build the capacity of our students and to challenge them. And that's really what we're aiming for. So again, tonight, I'm hoping that we'll come away with some, not just ideas, but also a pedagogical stance that allows us to engage with all of the incredible innovations that a lot of you have already talked about and different strategies, but that our stance itself is a real thinking stance. And we can do number talks, and we can do math congress, we can do different forms of consolidation and provocations, and that with each of those, we can bump up the thinking that's happening. I'd like everyone, if we can maybe get the timer for about 3 minutes, I'd like you to respond to one of these 2 prompts. If you want to respond to both, you can, but you can decide which one you feel called to respond to right now. And to create a little thought space for yourself, whether on a piece of paper or on your computer, and to spend a little time just writing down your initial thoughts to one of these 2 questions. Okay, so again, if we can get a maybe 3-minute perfect, and people to take some time to do that. And you may want to think about what it means to think like a mathematician if you're responding to that question. And even if you're not, if you want to spend the last minute here considering what does it mean to think the way a mathematician thinks. Great, thank you everyone. I think it's important to just spend a little bit of time collecting our own thoughts and activating our own schema as we dive in. So I want to put something forward that's come to me after a number of years now teaching mathematics at both the junior and intermediate levels. When I first started teaching, I felt like an accountant of expectations. And I struggled with that feeling. I felt like, my teaching was really focused on covering the curriculum, this idea of covering. And I've really challenged myself over a number of years because I did not feel that really served my students in the way that I wanted or needed it to. And my stance now is one where I see my mathematics classroom as the place where students learn how to think like a mathematician, and the curriculum is what we think through as we develop that. So for me, the core stance is we're learning how to think mathematically, and we do that through the various concepts that emerge at a particular grade level, rather than just saying, okay, this is what we do in grade 7 and this is what we do in grade 8. And I'm not saying that's not important, but my stance has become what we do is we learn how to think the way a mathematician thinks. In 1989, this idea was really starting to emerge of looking at the way we're teaching mathematics, and challenging the idea that we need to cover these concepts. But in fact, focusing on the thinking and focusing on becoming a good thinker is much more about the habits of mind, the dispositions of interpretation, of sense-making, that is just as important as acquiring a particular skill set or a particular strategy or even the core knowledge. And I think that we've been moving in a direction where we're really starting to recognize that it's the sense-making, the problem-solving, the habits of mind that a student brings, and making that much more of an explicit focus in our classroom. We're seeing that that really makes an impact on student understanding, student enjoyment of mathematics, because we know that a lot of our students have some anxiety, and they come to us. For those who are intermediate teachers, they can come to us already saying, I'm not a math person, right? And how do we challenge this idea? So I'm sorry, someone's having some issues here. Tracy, you're not able to see the slides? I'm not sure, maybe Mally can jump in and help you. You might need to log out and log back in. So I've got a little question here. And I just want you to think about this. And this is geared, for students probably upper primary and low junior. But I want you to think, just look at this question through the eyes of your students for a moment, and what you might anticipate, how you might anticipate your students would respond. And if you want, just quickly in the chat box or on the slide itself, what conceptual understanding is this question addressing? What conceptual understanding is this question addressing? Right, Vanessa, that the equal sign stands for is the same as. Equivalent. And again, think about how many of our students develop the idea that equals means the answer is, right? And so the conceptual understanding is missing because they've just developed this cursory notion of equals means answer. And how do we, and this is just a simple example, but I just wanted to surface how we continue to frame our tasks and questions to ensure that that deeper conceptual understanding is our focus. So why should we focus on quality thinking in math? Well, critical thinking emphasizes the idea that you need to be thinking for yourself. We can help students develop the metacognitive and self-regulation skills that really support their learning. And we have more options for adapting instruction to meet the needs of students when we're really focused on the thinking. And I'm going to talk about that and how the intellectual tools or thinking tools is just another way to say that. The tools we use when we think, and when we make those tools the framework, we can be more supportive in the kind of feedback we give students, in helping us to be more explicit in what we're assessing, and also in how we're framing our tasks and challenges. So again, one more, thinking about what's the best way to represent a two-digit number to show its meaning. So what's the best way? And our criteria for judging best way, we can think about, right? What would be the criteria you would use with your students to judge the best way to represent a number? Right? And think about all the different representations. How do we represent, what's the best way to represent the relationship between circumference and diameter? What's the best way to show that? What's the best way to represent the algebraic equation? Again, what would your students say? How do you think they would respond to this question? And what's our criteria for best way? That shows its meaning. Okay, so in both of those examples, I'm sorry, let me just get your point. My students would say all are correct, but 7b plus 4 is most efficient. Okay, and that, I think, Jeanette, that would lead to a really interesting discussion about what is the best way, and is best efficient? Is best, if we're showing meaning, you know, well, are all of these accurate, for example? Some might say that the number line, right? That's not you know, that's not accurate. The jar of pennies, that doesn't really give you a sense of the amount potentially. There could be a lot of different conversations, you know, that students could enter into around this best way of representation. And I am showing this example, and I want you to think about all the different ways or the concepts that you're working with, and how you know, offering these choices is a way to really generate some really productive discussions. And Shazadi is saying, for my students, is counting the coins money because it's life related. And kids, absolutely, different representations highlight different attributes. And that's why we would have to really dig into the criteria and say, what is best? How are we going to decide in this situation what best means? Yeah, so the 74 at Candace is not in the right place, right, on the number line. So that wouldn't be accurate, right? So it'd make us have to look closely about best, and maybe best is also about accuracy. That would be one of the characteristics. So what we've just done with both the examples I've given with the equality sign and the representation is given an example of a critical thinking challenge. Critical thinking, there's many definitions of critical thinking, and the one that we use that's been developed over many years at the Critical Thinking Consortium, which is teachers, principals, superintendents, university professors, people who are really interested in thinking. The definition we've developed is a pedagogically useful definition. It's not the only definition, but it's a really pedagogically useful and sound definition. And so what we're working with is the idea that critical thinking is thinking through a problematic situation about what to believe or how to act, where the thinker needs to make a reasoned judgment that reflects competent use of the intellectual tools for quality thinking. We're going to talk in a moment about what those intellectual tools are. But I think it's really important with critical thinking is to understand that in certain contexts, when we're thinking critically, it naturally might invite a critique, but the root of the word critical is the Greek criterial. So it is criterial-based thinking. It's that criteria that invites and almost forces the reasoned judgment. So we're going to talk about that. We're going to look at some questions where you can really see this difference. So a person is thinking critically if he or she is judging or making choices among options in light of criteria. So Sarah's talking about using counterexamples to justify reasoning, extend my thinking by using counterexamples, communicate my thinking so that others can understand, right? And absolutely we can co-develop the criteria with our students. And the counterexample kit, I agree, is really, really enlightening. It's like from the Frere model, the non-example can be so powerful. So again, in this situation, you were having to decide, we need to unpack what best is. We could co-construct that as a class, 2 or 3 characteristics of what best means in this scenario. And then students are judging in light of these options. They're having to decide in light of these options and in light of our criteria for best. We're gonna get to a little bit more around this in just a moment. So a thinking mathematics classroom, it's a classroom where students are not only learning to think, but they're thinking as the way of learning. Thinking is the methodology. It's not something we do at the end, you know, after we've learned a bunch of stuff. We're learning the stuff, and I put the stuff in quotations, through thinking. It's the way to deepen and engage with students' understanding of the subject matter and curriculum. So to create a thinking mathematics classroom, we want to be shaping the climate that supports thinking, creating those rich opportunities for thinking, building student capacity to think, and ensuring that the guidance and the feedback that we give students is really informing their thinking. And along the bottom, you'll see the 5 intellectual tools or thinking tools that are at play whenever we are engaged with quality thinking. When I gave you those tasks, you were bringing to bear your background knowledge, your understanding of the numbers, your understanding of the representations. We're using criteria for judgment, and we didn't have a clear conception of best, and so it was actually difficult to completely engage in that task as a form of reasoned judgment because we didn't yet have our understanding of best worked through. Students need to have a sense of thinking vocabulary. Do they, when you ask them to analyze, do they understand what that word means? When you ask them to infer or to create a conjecture, do they have an understanding of the language? So students, we need to be explicitly teaching and supporting students to develop thinking vocabulary. Students need thinking strategies. It can be as simple as a pro-con chart. A number line is a thinking strategy. Some of the ways of organizing problem solving, the Polya method, is a kind of thinking strategy. It's a way to think through a problem. So there's thousands of these. There are many, many different ways that we support students to make their decisions. And of course, habits of mind. So, these are the habits of mind of quality thinkers: open-mindedness, attention to detail, and perseverance have been highlighted as the 3 most important qualities, habits of mind needed for mathematical thinking. They're not the only ones, but those 3, attention to detail, open-mindedness or flexible-mindedness, and perseverance, are so integral to being a good mathematical thinker. So, this is a cartoon that I sometimes show because I love Calvin and Hobbes primarily. But, just thinking about, in this instance, let's say we're doing our observations in our classroom as part of our assessment. What might Calvin need? When we put on the lens of the intellectual tools, what is it that Calvin might actually need? Feel free to put something in the chat box. What do you think Calvin might need? If you think about the intellectual tools, we talked about background knowledge, criteria for judgment, thinking vocabulary, habits of mind. put on those lenses and see what, based on this observation, do you think Calvin might need? Right, so some background knowledge of number sense, an understanding of quantity, manipulatives perhaps. And again, it's important, manipulatives, and I'm glad you raised this point, manipulatives are definitely a tool, but it would be, a thinking strategy would be something really specific we do with those manipulatives. So they're really important, the tool of a manipulative, but in order to be a thinking strategy, there'd have to be something very specific with a particular manipulative we're asking students to do. Kevin says an attitude adjustment. Yeah, I know. Estimation, risk taker, confidence, experience with numbers and quantities, the sense of the number, right? A thinking strategy, Maria, absolutely to help him figure out, what the sense of proportion. He has no way of putting his head around that. Growth mindset coach. Criteria for reasonableness, absolutely. Manipulative, habits of mind, basic skills. Great. So excellent answers. So again, this lens of the thinking tools really supports us to move beyond sometimes we sometimes get stuck at just the level of, sometimes at personality with students, like, okay, this student isn't doing this, or he's not doing that, or she's not doing this. And when we have these tools as our frame, it empowers us to be able to make the interventions that we need to make to nurture the thinking. When we put quality thinking at the core of our stance, we are nurturing students who learn to think and think to learn. I don't think that critical thinking is, when we're thinking critically in math, we are thinking the way a mathematician thinks. It is not in addition to. Mathematicians are critical thinkers. So when we're nurturing that kind of thinking, we're nurturing in students the ability to think like a mathematician. So we're going to look at how we can bump up the critical thinking. And for some of you, this is a review. I'm going to give you the chart of the 3 different types of questions. So if you've seen this question chart before, I'm going to challenge you to try to come up with your own type 3 question, perhaps for something that you are going to be teaching next week. And for those of you who aren't familiar, then what I'd like you to do is think about what the key difference is between the type 1, type 2, and type 3 questions that you see here. And feel free, when you're ready, to write in the chat box about what difference you see between the type 1, type 2, or type 3. Or if you created your own type 3, please feel free to add that to the chat box as well. Okay, so Charlotte's saying type 1 seem more closed-ended. Type 2 are more like opinion. Type 3 is the most open, more open-ended. Okay, so yeah, the type 1 questions, I affectionately call these the Where's Waldo questions. They're not bad questions, but they are close. There is a right answer. There's a right or wrong. There's no in between. You know, there's an answer. You just have to know either how to solve the algorithm, or you can find the answer somewhere. The answer exists. And absolutely, type 2 are more personal preference. There's actually no right or wrong to type 2. You know, you can't go wrong. Do you enjoy finding patterns? Yes or no? I mean, it's really your preference. The type 3 are more critical inquiry type of questions. There isn't a specific right or wrong, but it doesn't mean though that all answers are good answers either, right? It's not an anything goes. You are using some criteria, even if it's not there specifically, it's implied. You know, the criteria of with how similar, that's the extent of similarity. There's some criteria there. Which table in the room is most likely the longest, right? So how likely is it? So there's a kind of plausibility that's implied. Joshua told me that any shape can represent 2/3. Can this be true? So an implied criteria of, well, truthfulness, right, in mathematics, whether that, you know, there's a proof, whether that can be proven true. With the first one, 4 numbers are missing. What might the counting line look like, and what numbers might be missing? Again, there's a sense of plausibility and accuracy that's implied. So there is criteria that's inherent in those questions, even though they're open. So that is a really interesting dimension to focus on in our mathematics teaching, is supporting students in being able to make those kinds of critically thoughtful decisions and self-regulate as they do so, right? So again, just a little review here of what we talked about, right? If we're looking at the type 3, there is some investigation that's often needed, building on curiosity. You do need to justify your answer with evidence, and a classmate could justify with a different answer, and also have some strong evidence. And again, you do have to make a decision, and you are using criteria to help you make that decision. So I want us to spend some time right now translating our understanding of these effective questions. And again, type 1, type 2 aren't bad questions. We use them in our classroom. But when we're talking about effective questions in the context of really bumping up the thinking, we believe that there are 6 key ways. We call them the 6 prompts, 6 key ways that we can take any question and turn it into a critical thinking question. And it's great when you have an understanding of these 6 prompts. I think of them as this amazing little tool set in my own toolkit as an educator, because I can then bump up the thinking in whether larger, overarching, rich task inquiries, whether in a consolidation question, whether in a provocation at the beginning of my class. When I have an understanding of these 6 prompts, I can take any question, a question from a textbook, a question from a various resource, and whether with the question itself or in a consolidation or what I ask students to do with it, I can bump up the thinking. So we're gonna play a little bit. We're gonna do which one of you doesn't belong with the 6 prompts. And again, for those of you who might have been in a presentation where I've talked about the 6 prompts, I want to challenge you to come up with an original question in one of the 6 prompts when we're going through them. Is everybody ready? Okay. So here we go, the 6 prompts. So first way that we can frame a critical thinking question is critique the piece. Okay, so take a look at the definition, take a look at the 3 examples, and your job is to figure out which example does not belong, and then tweak it so that it meets the criteria for a critique the piece, okay, so that it matches. So take a little moment to do this. Any thoughts on which one doesn't belong? Which one does not meet the definition of? Okay, yes, absolutely, number 3. And I saw someone had a good tweak. I'm just going to scroll up. It was really good. Is our collected data biased, or is it a good sample size? So there, I would just tweak that slightly, because even there, that could be a yes or no question. So thinking about perhaps even tweaking the question to say, was the data assess the degree to which the data collected is useful for our particular purpose, right? And again, we're really wanting to make sure that the criteria is at the forefront and it's not something that's a yes or no question. That's what bumps up the thinking. Okay, so we're assessing the merits or shortcomings of a person, product, or performance using criteria when we're critiquing the piece. Okay, we'll look at even some more examples a little bit later. Second type of critical challenge is a judge the better or best. This is where we're judging from 2 or more options which one best meets the identified criteria. So again, looking at which question doesn't belong. So Anik, I'm just going to respond. You said, how about what might this data be useful for? Again, not a bad question, but that again isn't asking students to make a decision in light of criteria. That could be more of an open-ended list. And then you could say, of these, of the different things we've proposed of it being useful, which one would be most plausible for us? Right? You need to have the judgment. Yeah, the criteria is what really forces the judgment. That's why it's so important. Thank you. Great, Megan. So number 1, absolutely. Which of our representations is the most concise or accurate? And you're right. It's number 1 that doesn't quite meet the criteria. Okay. So I just want to make sure everyone's had a chance to get that. The third type is rework the piece. This is where we're transforming a product or a performance in light of additional information or an assigned focus. Okay, so again, taking a look and seeing which one does not belong. How to rework is a challenge. I know, it is a challenge. So yeah, some people have come up with some different things like, I'm trying to remember now. Sometimes talking about is our method for determining the probability, or rework our method for determining probability so that it is more effective, for example. That may not be the strongest, but sort of look at our ways for considering probability or assessing probability and make it a more effective method, for example. So you'd be reworking. One of the things I wanted to point out is so often, you know, as teachers, we tend to focus on exemplars, like we're always wanting things to be the best or most accurate, but a really powerful way of learning, as was mentioned before when we're talking about non-examples, and a creative way is to give students that opportunity to do things like an unfair game of chance, like the first example, or I want you to construct a very ineffective solution for a problem, and then you can unpack the criteria in sort of a fun way like that as well. So just a little reminder about that we often go to the exemplar, but the non-example as criteria can be great. So how would we change our probability method for the probability of the next vehicle being a car? Yeah, I think we'll have to keep working on that and tweaking it, but it's definitely, it's a good challenge, right? It's getting us thinking. Okay, the fourth prompt, the fourth kind of critical challenge is a decode the puzzle. So this is where we're suggesting and justifying a proposed solution or explanation or interpretation to a confusing or enigmatic situation. Okay, great. So a number of people are saying that number 2, and yeah, that is the non-example. Any sense of how you might tweak that to make it more of a decode? How might we use pattern blocks to show the patterns in Goldilocks and the 3 bears? And again, so Megan, my one little tweak would again be that introduction of criteria. So even saying something as simple as, how might we best use pattern blocks to show the patterns in Goldilocks and the 3 bears? Because it really is that criteria that invites the reasoned judgment. And that's where we bump up thinking. So we have to be thinking about our criteria. That's really, really important when we're working on our questions. That's the tweak so often that our great questions are sometimes missing. Okay, let's move on to, oh, here's another one here. Which of the 2 graphs best show the story of Goldilocks? Now that, Kit, is a great question, but more of I don't know that we've had it yet, what's called a judge the better or best. So that is a critical thinking question, not an example of a decode. Remember, a decode is that we're trying to, you know, justify or suggest a potential solution or answer or explanation to a confusing or enigmatic situation. There's something problematic. That's really interesting, Maria. Yeah, Michael used pattern blocks to show the story pattern of Goldilocks. What might be his thinking? That's really great, right? What is his thinking? How does he understand the story? That's great. Thank you, Kit. Thank you, Maria. Okay, so here's another one, design to specs or design to specifications. This is where we're developing a product that meets a given set of criteria or conditions. Yeah, and so it is, some people are, I'll wait a moment, some people are starting to put in an answer. Yeah, so it is number 3, and Maria, you have a great suggestion. Design a unit that could be used to measure, that could be used to best measure the dimensions of the desk. So I would just tweak that slightly with putting some kind of criteria, whether suitable, which would be most suitable to measure the dimensions of the desk. Again, it really is that when you think about it, and you think about what goes on in our classrooms, and how if we said something like create a title for the bar graph, right? That's a common prompt we might give. But when we tweak that and we bring the criteria in, now think about what's happening for students, right? They still might need to understand what suitable means or informative, but we are really directing them. We are really getting them to have to consider, that title beyond just, let me just get this done, right? Let me just write a title. So that's the role, that's the importance of criteria and why I keep emphasizing it. It's really at the heart of this, of the critical thinking. Okay, and another one is perform to specifications. This is one of the ways I like to think about this is it's something that happens in real time, right? You're performing or undertaking a course of action that meets a set of criteria or conditions. Okay, so any thoughts about which one doesn't belong? Well, you know what, and that's a really fair point, Stephanie. I mean, I actually really don't like timed situations, and so I wouldn't necessarily do something like this, but sort of for our purposes, just to think about it. But it's true. I mean, it's a good reminder of why sometimes time or pressured situations aren't always the best. Or sometimes when I do this, teachers are able to talk to each other. And that's one disadvantage we have in this webinar is you can't sort of talk to them like, I'm thinking it's that one, but I'm not sure. So again, seeing the importance at times of the collaborative thinking to get us to feel more comfortable putting our idea forward. So, oh no, I'm sorry. Yes, definitely your contribution would not be considered poor. We're all a community of learners here. Okay, so that's really interesting that a number of you said 1. And this one, just I put it out there, this one is probably one of the more challenging ones when I've done it. So, and Jeanette, your point about students feel that way. So this is where it's so important that we're thinking about how we create a community of thinkers. And I have found that one of the simplest strategies, but one of the most effective, is as simple as a think, pair, share. So if I was doing, let's say, something like this in class, I would have the students talk to each other first before opening it up to the whole class, because that think, pair, share can really, I have found, bumps up the number of people who then feel comfortable sharing their answer because they've had that chance to run it by someone. And what you're saying is a really important dimension of the framework is how do we best create a community of thinkers where they feel comfortable sharing. So Kit, I want to applaud your risk-taking because it really is number 3 that doesn't quite meet the criterion. And let's talk about that for a moment. With number 1, the students are solving the problem, and as they're solving it, they're carefully monitoring and adjusting. So that's the criteria. They're carefully monitoring, and they're performing that task of problem solving. With number 3, yeah, absolutely, there was no criteria. That's it exactly. There was just a task. There was no criteria. So that, that's open-ended, but again, where's the reasoned judgment the student has to make? All they need to do is create a very simple story of subtracting 24 minus 53, but we haven't really invited any kind of reasoned judgment. Okay, so Deanna, great point. The criteria was the numbers given. So in this instance, no, the numbers aren't the criteria. Because what's involved there is background knowledge. The students need to have an understanding of, subtracting 24 from 53. But when there's no options, really, and that's key. The attributes of a critical thinking task is there's some different options for them to consider. Here, any story where they subtract 24 from 53 would fit. There's no decision that they really need to make. They just need to perform the task. There's nothing they've got to decide really other than just, what's my story where 24 is subtracted from 53. That's all. Like there's really, even though they could have a different story, on what basis are they making their decision? All they have to do is subtract 24 from 53 and make a story about it. So I hope that's a little more clear. There weren't the options that the students needed to make a judgment around. Because these are the attributes of a critical thinking question or task. So maybe this will help just consolidate some of our thinking about the different tasks we've been looking at here. Deanna, sorry, I'm not sure I understand your question. The criteria for number 1, do you want me to go back? Is it back on the slide that you're talking about for number 1 and number 2? Is that what you meant? Okay, so notice that the criteria for number 1 is carefully monitor. So students have to be deciding, what does it mean to carefully monitor my progress? And you may have done some work with them at that point about what it means to carefully monitor one's progress and adjust your strategy if necessary. So they're considering whether or not they're engaging in a careful monitoring. With number 2, they have to decide if their contribution is constructive. So they need to understand what that means, what constructive means, and then assess the various contributions and try to make one that meets that criteria of a constructive contribution. And that's where they're deciding. Does that make sense? Okay. Great. So again, these are the attributes of a critical thinking task. So we can see that's really the difference for bumping up the thinking. I just wanted to give people a chance to really look this over and consolidate it. Right, so when they're using that evidence, for example, if they're carefully monitoring, they'd have to really prove to you, like, how is this an example of carefully monitoring your your thinking. They're going to have to give you evidence of that. So, and here's some really, really simple question frames that, again, you can use in consolidation in your everyday questioning, right? So, you know, is this an effective solution? Is this an effective problem? Which one of these strategies is more effective? What would happen if we change this number? Right? How does this strategy work? So there you're really trying to get at, you know, the accuracy, the conceptual accuracy is implied there. So these are just some different little ways that we're looking at effectiveness in the math classroom. When I talk to my students about an effective solution to a problem, we've unpacked that as a class, and we have 3 characteristics for an effective solution that we work with. An effective solution is accurate, it is organized, and it demonstrates deep conceptual understanding. And we've spent time unpacking that. So now students have really internalized that criteria. And it's amazing the quality of work that has really progressed in the class as they're now, when they're answering and giving a solution, they really understand those criteria. Sorry, I need to review how to use the 4. Yes, I will be posting, I'll be creating a PDF of some key slides, and that'll be posted along with the other links, definitely. I also wanted to mention, we talked about metacognition, you know, a little bit earlier it was mentioned, how important it is to have students thinking about their thinking. And these 3 frames, I brought these up in other webinars I've done, and I always like to bring them up for those who haven't participated to make sure that everyone has these in their toolkit as well. But getting students to ask themselves these questions. So, you know, I have had students who really struggle, you know, to be monitoring their progress as they're answering a question. And, you know, we've made little cue cards with these 3 questions on them. And at various points, we'll check in, and I'll ask the student to have these 3 questions beside them and just to return to them so they can monitor, you know, whether or not the approach that they're taking is helping them. And when we're building that capacity for self-regulation and metacognition in this way, I have to tell you that the number of questions I'm asked where it's focused on, am I right, and I'm the arbiter of it being right, that has significantly decreased in my classroom because we're really focused on building the capacity to either self-assess. I always tell them you need to convince yourself before you convince me that the answer is right. Or peer assessment, so creating that community of thinkers and that culture of thinkers is really important, and these prompts can really help, these 3 metacognition prompts. Right. And of course, now when a student will come to me, and rather than me saying, you know, yes, that's right, or no, that's not right, I often will respond with another question, and I think that's why the questions have decreased, as they say, oh, she's not going to tell you, she's going to ask you another question, and they know that about me. So does this, you know, does your answer make sense? I'll say to them, so I want you to look at that, does it make sense? And again, what we've unpacked the criteria for sense making. It needs to reflect what is true about mathematics, what they understand to be true about math in the world. It needs to answer the question. For example, these are some of the characteristics of an answer that makes sense. Or putting different proofs or solutions on the board and asking them, which one of these solutions would you consider to be most effective? So I'd like you to return now to your thought book, and we'll give about 3 minutes again, Mally, if that's okay, 3-minute timer, just to revisit your initial thinking and that you might want to revise or add, some of that initial thinking. Add to it, revise it. Okay, so the criteria for question making sense would be true about reflects what I know to be true about math in the world, and answers the question, are two of the characteristics I use around whether an answer makes sense, not a question, but whether an answer makes sense. Okay, thank you, everyone. And I just want you to notice, in doing this, in giving you a chance to write down your initial thoughts at the beginning, and then as we're going forward, having you revisit. This is often, I think what we struggle to do in education is providing that time or building in the capacity for students to integrate and revisit and revise their thinking. So we've just come out with a little quick guide that was based on the book we published 2 years ago, Creating Thinking Classrooms, and it's a quick guide to using thought books to sustain inquiry, and it has a lot of different ideas for across grade levels and subject areas of different ways you can use this thought book or thought space as a tool for more of the reflective, integrative kind of thinking, because it's thinking about these overarching, tasks or questions that lets you do that. Those of you who have been in some sessions before have talked about some of the open-ended critical thinking tasks, like for a grade 8 unit on the measurement of cylinders and prisms. The thing I do on the first day is I put up a picture of the Guggenheim Museum in New York, and I have students speculate, if we were to have to figure out the surface area of the Guggenheim, how would you develop an elegant strategy for determining the surface area of the Guggenheim? And we unpack what elegant means in mathematical terms, which is really exciting to see students move towards much more concise and coherent mathematical understanding. And it's a non-Googleable question, and then we revisit in our thought books as we learn about the various elements. For example, we learn about measurement of circles, and then they revisit their strategy. So I've been trying to model that this evening with this use of a thought space. So, whoops, sorry, I meant to go to. There's a great website called Open Middle. I don't know how many of you have heard of it before, and if you haven't, I love it. It's based on, it came out of, Dan Myers, who some of you may know. He's done a great TED Talk and really critiqued the problems in textbooks, saying that, they basically walk you through, there's no thinking in them because all you need to do is apply, the formula and solve the problem, and there's not a lot of thinking. And so what we need to do is take out information from those textbook questions and have them be more open-ended, to really get students grappling with the question. And so the site called Open Middle comes out of that idea that you sort of, take out that middle part of a traditional textbook question and make it more open-minded. So these are some questions from Open Middle, and I just wanted to share this resource with you. And again, while you might not see the criteria in this question, I just wanted to point out that not every math question is, inherently framed in the way that I spoke about with the 6 prompts. But those 6 prompts are really powerful as you're asking students to either communicate. You can use the 6 prompts to bump up the thinking in their communication. You can use the 6 prompts to bump up the thinking in the application of the thinking that's required. You can use those critical thinking prompts in really powerful ways around the tasks that you're asking students to do with the mathematics as well, or when they're putting answers up and you ask the kinds of questions that invite that thinking. So that's open middle. And of course, I know a number of you are familiar with Jo Boaler's fantastic site, UCubed. I love her site and I love her work. And I can't recommend, some of her videos. Her Week of Inspirational Math videos are just a wonderful way to build that kind of community of thinkers in your classroom. So I think that's a wonderful resource for doing that. And she's got great, rich tasks that are inviting a lot of thinking, a lot of the quality thinking and thinking like a mathematician. And again, one of the things to be aware of in math is that sometimes the criteria, what we've been working on a lot at the consortium with my colleague Laura Ginny Newman, is there's a lot of implied criteria in mathematics. It's not always as explicit. There's a lot of implied criteria around accuracy. There's implied criteria around effectiveness. There's implied criteria around plausibility that's embedded right in a question that's not necessarily there explicitly, but is certainly what students are needing to do in order to decide, in order to be able to address the question or problem that's there. So this is a really rich challenge. What's the secret code for those of you who haven't seen that or haven't seen UCubed. And it really is working on the complex mathematics that enables those brain connections to develop. So the more we're providing students with opportunities to do more complex mathematics, the more they become good at it. And one of the misnomers at times is that when students have a gap in the background knowledge, we absolutely want to address that gap. But I don't know that we do a service to students when we only get them trying to address that gap in a rote way that isn't having them engage in thinking. Because often if we've got students who might be struggling with some of the tasks, then what often happens is they're not given opportunities to better develop their thinking. It becomes, just let's fill the gap with something rote, and I don't know that that's really going to address the deeper conceptual understanding that they need to build. So that's just something to consider. Just want to see Stephanie's point. Yeah, absolutely, Stephanie. Jo Boaler has tasks that she calls low floor, high ceiling, which means that there's an entry point for all students, but there's also there's embedded more complex forms of the mathematics that students who are able to go there or can go there, but students can enter in. And again, there's an entry point for all students, and this is really the point. There's an equity issue. And we have to think about how we're nurturing that thinking for all students. When a student really understands something, how we know they understand it is because they're able to do these things with that knowledge. Yes, I just wanted to give people a chance to see that and thinking about when we really want to know if a student understands something, we want to create the opportunities where we're seeing them be able to do these things. We're able to see them either teach a concept to someone else or create it in a different way or question it according to criteria or relate it to something else, right? This is when we know our students really have that understanding. And when we're assessing thinking, we can assess through the tools, right? So we're considering whether students can draw upon accurate and relevant mathematical information. We are assessing whether students are able to make reasoned judgments using the criteria. We're able to assess whether they're using those key concepts that are related specifically to mathematical thinking, like proof, like conjecture. We are assessing whether they're using useful strategies to work through the mathematical task. And we're assessing their habits of mind, whether they're exhibiting those effective thinking dispositions. And we think about when we're framing our feedback around these tools, what will that do? How will really zeroing in on these intellectual tools as the basis for our feedback nurture student thinking and nurture student growth? And again, just looking at some additional ways we can bump up the thinking in the math classroom. So here's just some ideas. Right, so adding a qualifier, judging and selecting by adding simple words like best or most, can bump up the thinking. Seeking patterns and generalize what students are learning whenever possible, so helping to pick out and point out the patterns. The reworking of the piece, right? Changing the purpose, context, or richness of the problem, so trying something a different way, getting students to see it in that new context and think through it. And perform or design solutions that offer a range of different perspectives or interpretations.
Maria, Charlotte's wondering if you could go back a couple slides to the assessment page.
Oh, sorry, I think I missed that. I apologize. There we go. Sometimes my comments get bunched up and I can't see the new one because it gets stuck on a previous one, so I'm sorry about that. Yeah, and any questions or comments about using the tools as a lens for assessment and evaluation? And again, I've done some webinars where we just really dig into this and dig into assessment. And if you think that would be useful, then you might want to let maybe Mally or Syria know, and we could look to doing another one of those sessions. But when you look at this, I'm just curious how it's sort of landing or sitting in people around the use of the tools as a lens for assessment in mathematics. Any thoughts about that or questions around the assessment? I know that's the really critical piece, obviously. Yeah, Joan, that's absolutely true. You really do. You really do need to have your math content. You really do. It really does ask of us to be much more conceptually adept so that we can push the thinking. Right, okay, the critical thinking vocabulary. So really that vocabulary, think about the vocabulary of thinking that's involved in mathematics. And I use some of those words, like, do students know what a conjecture is, or an inference, or the difference between an inference and an observation? You know, that's some of the language, the thinking language, the thinking vocabulary involved, or to even things like construct, analyze. When you're analyzing a graph, like that language, or do they have an understanding of the language of the thinking in mathematics, the terms that apply? I wanted to let people know, just in our closing minutes here, you know, on our website at tc2.ca, if you are a partner board, and you would be able to find that out again on our website. There's a drop-down menu and it talks about partners. And if you see your school board listed there, what that means is that when you register for an account on our site, if you use your work email that's related to that particular board or school, then you have free access to a number of resources that are beyond the firewall. We do have a number of resources that are there for free. For example, a couple of years ago, I'm just putting it in the chat box, I've developed a tip sheet on mathematical reasoning, and those tip sheets for teachers are free. It doesn't matter if you're a partner or not. We have a couple of different great little tip sheets, so you can find that on our site. But we also have a series of over 80 lessons, tools for thought, that are related to the intellectual tools. And we have, I think, about 4 or 5 tools for thought lessons that have been developed around mathematics. So, example, monitoring your progress while solving a problem is there. There is visualizing a math problem, for example. So we've got a few of these tools for thought lessons. So I do encourage you to get on our site, see if you're a partner. If your school board isn't a partner and you want to become a member, it is $40 a year for a membership, and you know that's a decision you can make. But we do have a number of school boards in Ontario who are partnered with us. So just check that out, and I wanted to point out we do have these lessons there for you. Right, so yeah, here are some of the tools for thought. Visualize a math problem, analyze and check the solution, write reflectively in math and science, organize data in a table. We have a lesson on inference that you could tweak by using a math example, and monitoring your problem-solving progress. And here's just some of the references I brought up tonight. Joe Bowler at UCubed, our book, Creating Thinking Classrooms, which was published in 2015, and you know, has generated a lot of really important conversations, you know, in education and modern learning. Our website, the Open Middle site, and also some of the great open-ended questions come from Lainey Schuster and Nancy Caravan Anderson, and they've got 2 versions, a K-6 version and a 5-8 version, which are good questions for math teaching, why ask them and what to ask. Those give you some nice open-ended questions that you can, you know, bump up the thinking around some of the consolidation work you do with those. So just in the last few minutes, if there's any questions or comments or thoughts.
Yeah, I just have something to add. All of those resources that Maria just put on that previous slide, they'll be in the resource section, and that'll be available in the morning. It's actually live now, so everything will be updated before the morning. So everything's there.
So Deanna, what you would do is if you go to our website, tc2.ca, and there'll be a drop-down menu for partners on our website. I'm just going to actually go to our site so I can tell you exactly. So it says About TC2, and in the drop-down it says Partners, and our partners are listed there. So if your board is there, then you are a partner. And yes, Shazadi, TDSB is not, and I'm with TDSB, and that frustrates me, but TDSB is not a partner, unfortunately. So yes, I feel your pain on that. Any other questions? Okay, Vanessa, this whole question of summative assessments, I'm glad you brought that up, and again, that's been a focus of a webinar I've done just around how to frame critical inquiry units in math. I actually don't do summatives at the end. What I do is I make the summative the driver for the learning. So like the Guggenheim example, that would have been a rich task that in the past I would teach all the things about measurement and then give them this Guggenheim problem. But now I've shifted things, and I start my unit with the summative and then have students thinking through, and I'm scaffolding their learning so they're failing forward, I call it. So they get those initial speculations, you know, right off, and then we also are building a hook and meaning for the learning because now they have this task that is directing what they're learning. So I'm also getting less of those questions or comments about why do I need to know this, because I've made the summative the driver for the learning. Yeah, it's backward teaching and planning, but really it's taking it to the next step, Shazadi, by putting the task right up front, making it, you know, the first thing that you do and speculating, and then you build beautiful quality work as you go along in terms of what students are actually able to do because they've been given more of the time to reflect on their thinking. So I'm sorry, we are, so we can, it'd be great to do another session just on that, and I have done that in the past, because it does take some thinking through about how we do that, but I'm aware of time, and I know, you know, you're all very busy professionals, and I just want to thank you for joining me tonight. I hope that you found some things that have been useful, and again, if you have any comments or questions, please feel free to email me. I've got my email address right here.
So thanks, Maria. That's great, and I can see from the examples that you gave that people have things that they could be doing right when they get back into their classroom tomorrow. So thanks so much for that. Just a couple of things from OTF, and I know that we're just a touch over time. So the first thing is where OTF is hoping that you'll provide feedback for the session for today. So you can do it in 3 ways, and one of them is just by simply clicking on the link that's right on the whiteboard right now. The second one is that you can, as soon as you log out of the session, you'll be able to, it'll take you directly to the survey for the feedback, and once you've completed that, you'll be sent a link that you'll be able to download, that you can download a certificate of participation, and that's great for professional portfolios. Another couple of things from OTF, there's sessions that are running all the way until the middle of middle of December. So these are the next 4 that are coming up in the next week. And so you can go and register for those on the OTF Connects website. And there is, I think there still might be some funding available. I'm not sure. You can look into it if it's something that you are interested in. But there's some funding through the Ministry of